guys, so today we are going to talk about maximum sum subarray problem, and we are going to see a brute force approach and how we can improve its running time from cubic to quadratic, and then we are going to apply divide and conquer technique to this problem and improve its running time to order of n log n. And then in our next video we are going to talk about Cadney's algorithm, which is a game changer and will solve this problem in linear time. So let's get started. Maximum sum subarray problem, we are looking to find a non-empty contiguous subarray whose values are largest sum. So we are looking at a contiguous subarray and not non-contiguous. So what do I mean by that? So if I take these three elements, this is not a contiguous subarray because 5 is missing in this element. So we are only looking for continuous subarray. Now this problem is also only interesting when there are negative numbers also. So if there are all positive numbers, then the maximum sum array definitely will be the sum of all these elements. So now let's see how we can arrive at a brute force solution. So it is straightforward. We are going to find out all the subarrays in this array, and then we are just going to find out which one of that subarray has maximum sum. So let's list out some of the subarrays of this array. So subarray of size 1 will be these, and then subarray of size 2 will be these, and then subarray of size 3. Okay, I think you got the idea. And now let us see how many number of subarrays are present in this array. So if there are n elements in this array, there will be nc2 subarrays in this array. So if you are wondering how did we arrive at nc2, so see here, if we select any two elements from this array, for suppose I select -1 and 5, so this is considered as my first element and this is the last element of the subarray. So if I am selecting these two elements, that means I am selecting this subarray. This way I am selecting all the two unique elements and they will give me the starting and the ending points of my subarray. So nc2 will be theta of n squared. Its value will lie in. So at max we can hope is our algorithm will run in omega of n square time. That means the lower bound is n square. We have to compulsory do n square computations because there are n square subarrays there. So let's see how we can code this brute force algorithm. So let's run one loop. I starts from 0 till array size, and let's take two more variables, max sum and sum. Sum will be initialized to 0 and max sum will be initialized to a negative value. So in Java you can use something like integer dot min value. Now we will take one more loop. So let's take one example also side by side. Okay. So this loop is going to choose our first element, and now there will be one more loop which will start from I and which will go till array size. This is going to select our last element of the subarray. If it select this, then this is our subarray. If it select this, then this is our subarray. So if I select this and J select this, this is the subarray that is selected for now. And now there will be one more loop which is going to sum all these elements between I and J, between our selected subarray. So K will start from I because this is our starting element, and it will go till J. Okay, and now sum will be sum plus ARR of K, and let's take an array here as well, which is this number 3, 5, -8, okay, 6, -2. Now, so after this we are going to put here one check. If our max is less than sum, then we are going to update our max variable to sum, and now here we are going to clear the sum variable so that next subarray can be again added over here afresh. So this is the brute force approach. So this loop, outside loop, is going to run n number of times. It starts from 0, it goes till n minus 1. So it is going to run n times. Now this loop is starting from I and goes till n. So if i's value is 0, it goes from 0 till n minus 1. That is, for value 0, it runs n number of times. So for value 1, it is going to run n minus 1. This way, both the loops are going to run in n square time. Okay. Now let's talk about this third loop. So this is little interesting. So it runs for value of I comma j. So when this pair is 0 0, that means the size of the array is only 1 or 1 1 2 2. If these are the ij values, then that means we have selected an subarray of size 1. In that case, it is going to run only one time from I till j. So one time, and how many subarrays are there which size is 1 is n. Okay. Now subarray of size 2. So there are n minus 2 subarrays of size 2. So n minus 2 times it is going to run, because it is going to run from I to j. And how many subarrays are there of size n minus 2? N minus 2. Similarly, n minus 3 into n minus 3. So this way, if you sum up, these is odd. Okay, so this value will be roughly n square. So this way we are going to get into n square, which is order of n cube. Now let's see if we can improve this algorithm and its cubic time complexity to quadratic. Guys, let us discuss how we can improve this running time of cubic to quadratic. So if you observe a pattern here, if for suppose this was my subarray, this is essentially this maximum subarray of this subarray plus this value. So essentially what we can do is, if we have already calculated the maximum subarray for 3, then 3 comma 5 maximum subarray will be this plus 5. So we just need to add the element in already pre-computed sum. So if you observe, this loop is completely unnecessary here, where we were iterating over the number of values inside that subarray. So if we remove this loop, we can directly calculate our sum here, sum plus ARR of j, and then here we can check this is fine, and then let's clear out our sum array here when we enter this loop. So what is happening here is, first time when I is 0. Now first time j is 0. So it will start from here and it will add it in the sum 3. Now 3 will be checked with max, which is this thing minus infinity. So 3 will be our maximum sum subarray for now. Now next, when I is still 0 and j is 1. So I is 0 and j is 1. Now it is going to add 5 to our sum, and it is going to become 8. Our sum is going to become 8, and again it will check with max. So what we are essentially saying is, I will be here and we will be taking up all the subarrays which start with 3. Similarly, we are going to 5 and we will be taking up all the subarray which starts with 5. 5 minus 8, 6 minus 2. And then we'll start with minus 8 and we'll take subarrays all the starting with minus 8. So it will be minus 8, then minus 8, 6, and then minus 8, 6, 2. So this way we have removed one loop which was unnecessary, and the running time of this algorithm is now order of n square. Now guys, let's talk about how we can apply divide and conquer technique here and improve this problem's running time to order of n log n. So guys, in divide and conquer approach, if we have been given an array So usually in divide and conquer approach, there is a step to divide the given problem into sub problems, and then there is a step to conquer it. That means this particular work we are performing all the steps. We are dividing and then performing this work. We are dividing and performing this. So our divide step is to divide this array into half, and then our conquer step is to find the maximum sum subarray. Okay, so in divide and conquer technique, what we are going to do is, first let's observe something. Suppose this is the array. What could essentially happen is, suppose this is the midpoint of the array. Either our maximum sum subarray, from now onwards I will call it MSS, either MSS can lie in this left subarray or in the right subarray, or it could cross the midpoint. And when it will cross the midpoint, it has to compulsory take this element plus this element. They both has to be there for it to cross the midpoint. Because if only 8 is there, then it will lie in left subarray, or only 6 is there, then it will lie in right subarray. These both has to be there. Now what we will do in this is, we are going to recursively divide our problem into half until we arrive at when there are only single elements and we cannot divide this array sub further, and then we will check whether the array lies, and then we are going to find out the left subarray sum, the right subarray maximum sum, and then the subarray which is crossing them, and out of these three we are going to pick one which is having the maximum sum. So let's take this example and let's see how our algorithm will move further. So it will be divided into two steps. So now we will have 2, 5, 8 in our left subarray and 6, minus 2 and 5 in our right subarray, and then it will be further divided. So it will be 2 and minus 5, 8 in our one left and right, and then here it will be 6, minus 2 comma 5 in our right subarray, and then this cannot be further subdivided. So what we will do is, we are going to return 2 for this. And now this subarray can still be further subdivided. So it will be divided into minus 5 and 8. So now this will return the left sum as minus 5. This will return the right sum as 8. And the one which is crossing the midpoint is the sum of these two. So it will be 8 minus 5, 3. So minus 5, 3 and 8. Which one is the maximum? Right sum is the maximum, 8. So 8 will go from here till here. So this will be the right sum for this subarray. And this has returned 2. And the one which is crossing the midpoint is 2. 2 compulsory has to be there. Minus 5 is also there. So till now it is minus 3. Plus let's see 8 increases the sum or not. 8 does increase the sum and it is 5. So 2, 5 and 8. So right subarray wins and it is going to give us 8 at the top. So this left subarray has given us 8. Similarly, you can calculate here what's the value, and this way we can find out what is the maximum sum subarray. So the only problem which is left now is, how do we calculate the subarray which is crossing the midpoint? So let's talk about it. So guys, this is the algorithm to find the maximum subarray which is crossing the midpoint. So we are going to find MSS which is crossing this midpoint, so it has to compulsory take both these elements. And now the MSS which is crossing this subarray is itself composed of two more subarrays. The one subarray which starts with this element and go towards left searching for any maximum sum, and the other subarray which starts from this element and moves toward right searching for any maximum sum. So compulsory we have to take 2. So we take 2, and then let's see this algorithm how it works. So we start with mid and we go till low. So guys, we will start with mid and we'll go till low in search of finding a maximum sum. So we'll keep incrementing a of I into this sum variable, and if we find at any step that sum is greater then left sum, we are just going to increment our left sum to sum. So initially our left sum will be a negative integer, the lowest possible integer that can be stored. So in Java you can give it something like integer dot min value. This is the smallest value computer can hold, and then what we are saying is, and it is important to initialize this to negative infinity and not 0, because in case where you have all negative numbers, if this value is 0 then we'll get the sum as 0 instead of getting -1 as the sum, right? This is the maximum sum subarray for this where all are negative. So to avoid that case we initialize it with -infinity and not 0. And so initially if you see here, sum will be, after first iteration sum will be 2 and left sum is -infinity. So sum is definitely greater than left sum. So now left sum will be updated to 2. Now in second iteration sum 2 will be added to 1 and it will become 3. 3 is greater than left sum. So now left sum will also become 3. So here the left sum is 3. Now similarly go towards right and perform these similar operations. So for right sum, after first iteration it is -3 and right sum is -infinity. So now add 5 into -3, we will get 2. And now 2 is still bigger than -3. So here the right sum is 2 considering both of them, and the left sum is 3 considering both of them. Now the max subarray will be the sum of both of them. So if we add both of them, 2 plus 3, we will return 5. So that is what we are returning. Return left sum plus right sum. So let's quickly see its running time for this algorithm. So if you see, this loop will run for half of the values and this another loop will run for another half of the values. So total number of elements, how many are there? N, and this entire algorithm is going to run n number of times. So its complexity is order of n. Now let's discuss the overall algorithm and find out its time complexity. So guys, let's talk about our main and final algorithm where we are going to call this max sum subarray from low to mid. We are recursing on left half of the subarray here, and then we are going to call find max sum subarray and we are recursing right, and this one is our base case. So when only one element is left, then we have already subdivided and we cannot further subdivide our algorithm, then we need to return that value, that single value. So in this left sum we are going to recurse it on the left half, and right sum we are going to recurse on the right half, and then cross sum is the algorithm which we just discussed, is going to give us max sum subarray and we are going to pass it low, mid and high. And then we are just going to check if left sum is greater than right sum and it is also greater than cross sum, we are going to give left sum, and if right sum is greater than left sum and is also greater than cross sum, then we are going to return right sum, else we are going to return cross sum. I think this is straightforward, guys. So let's discuss its time complexity quickly. So if you see here, if you want to form our hypothesis t of n is equals, so this is, it is dividing it into half, so 2tn by 2, plus this is also dividing the subarray into right half, tn by 2, plus this cross sum. So this algorithm takes order of n time, we just now saw. So order of n. So basically our recurrence relation will be 2tn by 2 plus order of n. We can say it as theta of n as well. So now if you have any doubt on how to form recurrence relations, how to solve these equations, so we are going to solve it using master method, and it is going to give us n log n, order of n log n. So if you have any doubt about master theorem, I have one more video on master theorem, please consult that. And we can also find out this time complexity using recurrence tree method. So we try to form a tree. So what we are doing essentially here is n sub problems are being divided into n by 2, n by 2, and these keeps further subdividing until we reach at 1. So what will be the height of this tree? So it will be n by 2 to the power k when we'll get it as 1. So what will be the value of k? N equals 2 to the power k when we take log n. Log n is equal to log base 2k. So k is equals log n. So height of this tree is log n. And what is the work we are performing at each step? Theta of n. So n log n is its time complexity. So we saw how we solved maximum sum subarray problem into n log n using divide and conquer technique. In our next video, we'll talk about cadence and we'll solve this problem in one pass and also in linear time.